Welcome back to the shop and to the channel. Today's project is this Lincoln AC 225 amp arc welder that I picked up off of, it was either Facebook or Craigslist, probably 3 years or so ago. It's pretty old, but these things just never die as long as they're, not dropped out of a plane or run over by a tank. They seem to hold up pretty good. Even the Stinger and stuff is pretty old, but it's still serviceable. Well, the leads and the work clamp are a little bit dirty. The work clamp's got a lot of spatter on it, so I don't know who was welding with this thing before, but anyway, those are still working, so I don't see why I would need to do anything with that. The selector knob on it is kind of stiff, so I might need to address that, but that should be a pretty simple fix with some dielectric grease. The wheels that it's sitting on are jacked up, and they certainly aren't original. Looks like somebody welded on some lawnmower wheels or something, but those are going to have to go. Whoever had it before me used a piece of dryer cord to power it, and that's not going to work either. Well, the first thing I need to do is to just take it apart. So we'll go ahead and get rid of these wheels and start taking the covers off and get a good look inside and see what might need to be repaired, or maybe it just needs a good cleaning. Well, for whatever reason, somebody prior to me welded the back cover to the sides, at least on the bottom here. No idea why they would do that. So I'm just using a cutoff wheel here to go ahead and cut these welds so we can get the back cover off. Well, the inside of this thing is a lot dirtier than I expected it to be. It is full of cobwebs, dust, and looks like little spiders' eggs, sacs, or whatever they're called, but it's gross. So we're going to need to clean this up a bit. Well, there's another panel here at the top of the welder that covers the selector switch and houses the fan. And since I'm going to take all this apart to clean it anyway, I'm going to just reach in and disconnect the fan wires from the power switch and remove the panel and the fan together. There's this block of wood on the front of the welder that's, I think, used to level it out with the rear wheels as they were. And these screws are kind of jacked up and stripped. So I'll just go ahead and use the zip disc again and cut them off. Well, while this thing's still on its back, I'm going to remove the screws that hold the amperage selector to the front panel. I want to take the power switch off now, and I needed to stand it up in order to get to the screws that hold it onto the front of the case. Well, I've got something different planned for these welding leads, but since I'm going to end up painting this case anyway, it'll be easier if I go ahead and disconnect them and remove them from the internal wiring. Well, there's a few things I want to do to this case before I paint it, one of which is to kind of fix these janged up ends on the panel. It's fairly well bent, plus where the weld was is kind of jacked up too. So we'll take a hammer and a makeshift dolly to go ahead and deal with those, try to get them back into some semblance of what they were originally. Well, the Stinger and the welding leads are definitely showing some age and some use, but I think I can still put these to use. I don't think I need to replace them, although I do have some options that I'm going to build into this. Well, the way these welders come and the way they're still made is the leads themselves have a lug on the end of them, and they are bolted to the internal wiring of the welder. But I want to do something just a little bit different. Well, on a modern inverter welder, and I've got several of them, they come with stingers like this, and they have a DINS connector on them, so you can easily swap out the stick stinger with a TIG torch or your MIG gun. And I think it would be pretty cool to add this capability to the Lincoln. I went on Amazon and I bought this set of DINS connectors. Now these are exactly like the ones that are on my other welders, and they take the European DINS connectors. These are 315 amps, so more than adequate for this Lincoln welder. Along with the sockets, it also came with the set of plugs, and so I should be able to use these on the old welding leads and be able to keep them together with a little bit of a more modern flair. Well, I'm going to make a plate that I can weld into the front of that case, and so I've got this piece of cold rolled in the mill vise that I'll go ahead and bore a couple of holes in order to mount those sockets. I want to take a second to again thank Anchor Lube for being a supporter of the channel. I've been using this stuff for years, and I find it to be one of the best all around cutting fluids, not just for drilling and tapping, but for general machining as well. If you want to try some of this yourself, there's a non-affiliate link in the description that will take you to Anchor Lube's Amazon store where you can pick up your own. With that new plate now bored out and deburred, I just need to mark on the front of the welder just where it's going to go. We'll get this center section cut out here. I've got a pneumatic die grinder with the zip disc in it, and we'll start cutting this center section out so I can weld in that new plate. Well, I want to minimize the gaps around this thing just to make it easier to weld. So now that I have it cut out with the die grinder, I'm using this little sander to fine tune it so that that plate just fits in there and will be a nice tight fit up. And welding that plate in, I think I'll go ahead and use my Arc Captain MiG 200 for this. It's got 023 solid wire loaded in it and perfect for this kind of sheet metal work. Well, I want this to be as smooth as a finish as I can, so now that I've got it welded up, at least on the sides here, we'll use a angle die grinder with a little mini flat wheel in it to grind down the welds until they're nice and smooth. Now that either side of the plate is nice and smooth, I'm going to fill the gap here at the top. And what I'm going to do is I've got some 1/8 inch TIG rod. I'm just going to take a piece of that. I'm going to lay it across the top. That'll at least give me some backing. And then I'll weld over top of that. And that should give me a decent contour to start with. Next, I'll take my little mini flat wheel here and grind down the surface of the weld to get it even with the rest of the front of the case. I want to give the top of this here a little nicer rounded contour so it sort of matches the radius of the stamped part of the sheet metal. So I've got a ball nose carbide burr in a die grinder to remove the bulk of the material, and then I'll come back and sand it down a little bit again with the flap disc. Well, I think that's going to look nice. So now I need to clean this up, finish some of that sheet metal repairs on the sides, and I think we'll sand it down and give it a coat of primer and a few coats of red paint. Couldn't find paint that matches this color, but I think what I found and I came up with, I like it, and so I'm going to use it.
12 seconds later.
With a fresh paint job on the sheet metal, I can put this thing back together. The new DINS connectors just mount into the holes in that new plate. Now these aren't made exactly the way they should be. The connector itself has a little key in part of the plastic. And I was going to bore these holes that had the key in it, but I didn't have a drill or a hole saw that was the right size. So I think just by putting these in here and tightening them down, they shouldn't move at all. I suppose if I need to later, I can take these back out and weld on something that would act as a key to keep them from spinning. But I really don't anticipate them spinning at all. And then I have some short little 1-foot leads that go from the DINS connector to the appropriate point in the circuit of the welder. This one here goes to the center of the selector knob. And I have this black one that attaches to the other connector that connects to the other end of the transformer. I removed the fan motor from the upper back cover, and this will make it a little bit easier for me to reinstall it and connect it to the power switch. For the incoming power, it's grounded to the inside of the cabinet. I did put a little primer on the inside of the cabinet here, so I'm just using this angled die grinder with a Scotch-Brite pad on it to take some of the paint off so the ground can have a good connection between it and the case of the welder. Then the two hot legs coming out of the power lead can be attached to the other side of the switch. Well, I cleaned up the contacts on the selector with some Scotch-Brites, and I'm just going to apply a little bit of dielectric grease to them as well. Well, I can install the upper panel here into the back of the welder. One thing to be cognizant of is that one side of the transformer, since it's just kind of floating there, to be sure that it's not making contact with any of the sheet metal on the outside, which would end up causing a short and potentially be dangerous. Well, with that upper panel installed and all the wiring, I can now install this lower panel. Not only does this enclose the rest of the wiring, but it adds some structural stability to the whole welder because it attaches the sides, get attached to the back as well as to the base of the welder and kind of ties it all together. I thought about getting a replacement for this control plate. You can find replicas online for less than 60 bucks, but I kind of felt like I wanted to keep a little bit more of the original welder, so I opted to keep it. Since I've modified the front of this thing and given it a paint job that doesn't really match Lincoln Red, I figured I would just keep this panel on the front as it was. Well, I have a plug on the end of the power line and it's plugged in, so let's throw the switch and see what happens. Well, besides the hum from the transformer and the noise of the fan, that was happily uneventful. So I'm going to put some welding leads in these connectors and see if we can't burn some steel. I like to spray down my welding table with this Forney anti-spatter spray. It actually does a really good job of keeping any of the welding BBs from sticking to this welding slash fixture table. Got some scrap material here with some 3/32 7018 rods I picked up from Harbor Freight. We'll see if we can't tack these together and run a fillet weld. Well, I don't usually have issues with 7018 burning through mill scale, but this seems to be giving me a little bit of trouble, so I'll use this flap disc to clean off some of that mill scale and try it again. Well, that's a little bit better, although it did take me a little more effort than I guess I'm used to in getting it to hold an arc. I'm just having one heck of a time in getting an arc here with this welding rod. This is, like I said, some 3/32 7018 that I bought from Harbor Freight a couple years ago, maybe 3 years ago, so it's not that old. My shop isn't very humid, so they should be okay. I don't keep them in an oven or anything, but I haven't really had this much trouble with the inverter machines in getting an arc to strike. Maybe it's the rods, maybe it's the machine, maybe this just needs a better quality rod than these ones from Harbor Freight. Well, I've tried different amperage settings between 75 and 115 amps, and I'm getting various degrees of success. Not able to get this arc to start real easily, and it is a little bit tough to maintain it. That, work to contact tip distance is pretty finicky. If I vary it even a little bit, I'll lose the arc. Well, I'm going to switch gears just a little bit. I've got some 1/8 inch rod here that I bought from Menards. This is still 7018, and I've used this stuff before with the inverter machines, and again, really easy to start an arc. And this actually didn't go all that bad. It took a couple of tries to get the arc started, and maybe that's just me not used to a transformer machine, but once I got it started, it was a fairly stable arc. I didn't see any fluctuations with it, and I was able to push this rod in the whole way. Well, maybe that first stick of 1/8 inch was a fluke, so we'll give this another try. And yeah, that arc started pretty simply. Maybe it's because the material is pretty hot at this point, but that started up real easy, and the arc was really clean. So I don't know. I think those Harbor Freight rods are just junk for a transformer machine. I may pull out one of the prime weld machines to see how they do with that. Maybe I'll just stick with using them on an inverter. Well, I'm not going to win any welding contests with that. It's a little bit undercut here at the top, but I think overall it welded just fine. I think the welder is running exactly the way it should be. There's a few more things I want to do here before I can wrap this project up. I got this piece of 1/2 inch all thread for an axle and some lawnmower wheels. I think they'll work a little bit better than the jacked up ones that were on here before. Now the bottom of this thing has these two, I don't know if you want to call them feet or not, but through the middle of them there is a hole that this 1/2 inch piece of all thread will fit through, and I want to capture it with a couple of nuts and some washers. So I'm feeding a nut on the end of the all thread as I bring it into one side, and I'll thread that all the way through, and then when it comes out the other side, I'll put another nut and washer on it, and that will capture this axle, at least in some kind of position. Now this is going to seem a little disconnected, so stick with me here for a little bit. I want to put a handle on this thing, and before I can finish the wheels and put the wheels on, I want to make the uprights for this handle. So these two pieces here are going to be the uprights, and they're going to be attached to the sides of the welder from the axle all the way up to where the handle is. And I need to drill holes in these, and I want them to be exactly the same, so I'll drill them at the same time. But to ensure that they all line up, I'm going to just tack weld these things together, and then I'll drill the holes and break the welds later. Well, the position of these holes really isn't precision, but I wanted to get close, so I just have some marks on the top piece here, and I'm going to use the Bridgeport to go ahead and drill the holes for the mounting hardware. All the way down here at the bottom of these uprights, I need a 9/16 inch hole for the axle to go through. Well, hopefully this will start to make a little bit of sense. But the first thing I need to do is take out this sheet metal screw that connects the side to the internal shelf, because I'm going to use that as one of my mounting points. I also made up these spacers to space off the uprights away from the side of the case. These are just a few hundred thousandths in thickness, and we'll reattach the handle through that sheet metal screw with a longer one rather, and then slide it over my little makeshift axle. Axle end, we'll put a washer on it before I slide on the wheel, and then we'll secure the wheel to the axle with a couple of nuts. I'll put one on until it's finger tight against the wheel, and then I'll put another one on as a jam nut. And I'll do the same thing to the other side of the welder. But I still want to secure it here up near the top. There's no other mounting hole, so I'll drill a hole through the case of the welder. I'll use another one of those spacers, and we'll just attach it with a nut and a bolt. Between the two uprights, now that I have fastened to each side of the welder, I'm going to put a piece of pipe in between to act as the actual handle. Well, to weld the pipe to those uprights, I'm going to fire up the Prime Weld MIG 180 here. I've got some 035 wire loaded up in the machine. Well, these welds don't look the best, but you know what they say, grinder and paint will make me the welder I ain't. With a coat of black paint on that handle, and I got it reinstalled here, I think we're all set. I did put a piece of wood under the front foot just to level out the machine, and I also put the DINS connectors on the ends of the original leads. And I do like having these DINS connectors on the front of the machine. It does make it a nice, clean look to it, and it's just a little more convenient not having them permanently wired into the front of this welder. The wheels and the handle on this thing make it super easy to maneuver and to pull it out, to use it, and to put it wherever I need to use it, and then put it away. I'm really happy with how that handle turned out. And this back shelf makes it real convenient to store the power cord as well as the leads. They can be tucked up in here and be out of the way when it's stored up against the wall. Well, that's it for this video. I hope you enjoyed it. I enjoyed doing this little refurbish modification to this welder. I really like having those DINS connectors on there. And it's fun to take this old school technology, quote unquote, out and use it from time to time. Well, hit that thumbs up button if you liked the video, and drop a comment down below. Did I break some cardinal rule by putting European DINS connectors on the front of a USA made old school Lincoln welder? Let me know what you think in the comments. Well, that's it for now. Thanks for watching, and we'll see you on the next one.